Hey everybody, what day is it? It's Thursday. Yeah. All right. Hey, you gotta be a little bit weird once in a while. All right, 528:20. Get down there. Learning targets today. I know the basic vocabulary dealing with chemical equations. And I can balance simple equations. All right, so here we go. Here's a statement. We have used burners in the lab, and when you light that burner, you're hooking it up to a gas supply, and methane is the compound primarily coming out of that. And what happens is the methane reacts with oxygen that was in the air, and it forms carbon dioxide and water. Okay? So, starting stuff turns into new stuff. That's a chemical reaction. And we can write it out in a nice sentence like this. Methane reacts with oxygen to form carbon dioxide and water. But chemists are lazy. The reason we've worked so hard to try to learn those different skills, the symbols and the ions and all that kind of stuff along the way, is because in the long run, that saves us a whole lot of time and effort. Because I can write this with much less effort. Let's take it apart. Methane. The way a chemist would write methane is CH4. You guys don't maybe know that one yet, although I suspect that some of you do. Reacts with, here's where we get the real savings, plus. Oxygen, O2. Remember, there are 7 common diatomic elements. Oxygen is one of them, okay? So whenever oxygen is by itself, it's O2. If it's in a compound, it might not have 2, but by itself, it's always O2. To form, there's an arrow. Carbon dioxide, CO2. You guys should know how to do that one. And water. I think you guys know this one. So that's how a chemist would write that out, except it's got a major problem. Because if you look at it, here's a carbon, there's a carbon, here's 4 hydrogen, and over there's only 2 hydrogen. Can we have 2 hydrogen just disappear? Don't they have to go somewhere? And there's another problem, and that I count 2 oxygen right here, but on this side, try to remember that this arrow represents the before and after. This side, there's 2 oxygen in that compound plus another oxygen there. So 2 oxygen somehow turned into 3 oxygen. I don't. Maybe one or those 2 hydrogen, could they turn into an oxygen? No. Even if it were possible to do the nuclear reactions that would be involved, if you think about a hydrogen atom only has 1 proton in it. So 2 hydrogen atoms would have a total of 2 protons. To make 1 oxygen, you need 8 protons. So no, even if the nuclear reaction were possible, you cannot turn 2 hydrogen into an oxygen. There is a problem with this reaction. And the problem is that it's currently not balanced. Okay? So these are the correct substances, but we have to go and figure out how to get the correct ratios of these substances. Okay? Now, carbon is already good, right? There's 1 carbon, 1 carbon. I don't want to mess with that. Now, there's 4 hydrogen here. There's 2 hydrogen there. What if I had 2 water molecules? What if I put a 2 in front of that? Well, now that would be, each molecule has 2 hydrogen and 1 oxygen. So you'd have 2 hydrogen plus another 2 hydrogen, 4 hydrogen. So when this reaction takes place, I produce 2 water molecules instead of just 1, the hydrogen is taken care of. Now let's take a look at our oxygen. There were 2 over here, and there were 2 there, and there's 1 in each of those water molecules. But see, when I put a 2 in front of that, well, 1 water molecule has an oxygen, and the other molecule has an oxygen. So that's 2 oxygen there, and 2 more there. That's 4 altogether. This side only has 2. But what if I had two of these. Hey, look, I didn't change my substances. This is still methane, this is still oxygen, this is still carbon dioxide, this is still water. But I changed the ratio. I said, if one of these reacts with two of these, I can produce one of these and two of these. Now, it doesn't violate the law of conservation of matter. I have the same number of atoms on each side. That is a balanced chemical equation. Okay, so we're going to work on it. Now, I know that we are really short on time, so as far as being able to take this and write this out, I'm going to pretty much just give you formula equations and ask you to balance them. Okay, so what is a chemical equation? It's a set of formulas and symbols that express a chemical reaction. Okay, and the very general form is reactants yield products. Okay, so vocabulary, reactants are those substances that enter into the reaction. Those are the things that we start with. In that last equation, it was methane and oxygen. That's what we started with. And then products, well, they're formed during the reaction. They're the things that are produced. You know, reactants react, products produced. That's not quite a good enough definition for a test because that's a circular definition, but, you know, think about it. Reactants are those things that react. Products are those things that are produced. The arrow is represented as yield. Now, yield, some people in driving think that yield means slow down. No, what yield means is to give way. You got to give way to somebody else. If you're looking at a yield sign, or if you're in a situation which requires you to yield, you have to give way. So we say reactants give way to products. All right. We might have, you know, I started with a sentence. We might do a word equation where we just give all the names, but we use some other symbols. We could get a formula equation that shows the correct formulas, but see, that's not balanced yet. So what we're really after is a balanced chemical equation where we show all the symbols and formulas and there's no gain or loss of atoms anywhere along the way. I've got, by putting a 2 in front of here, I've got 4 hydrogen atoms. By putting a 2 in front of my water molecule, I got 4 hydrogen atoms. 2 oxygen atoms, and 1 in each of these water molecules, so that's 2 oxygen atoms. The numbers that are put in front are called coefficients. And a coefficient multiplies everything in the formula. So just like in algebra class, if you put a 2 in front of x, it means 2 times whatever x was. X could be equal to some whole big complicated equation, but if you put a 2 in front of it, it's 2 times whatever x was. So this is 2 times whatever this formula is. This is 2 times whatever this formula is. For contrast, these little numbers, this is called a subscript. And it only refers to the element right in front of it. Unless there's parentheses, and then it refers to whatever was in the parentheses in front of it. Again, we're pressed for time, so I'm not going to dwell on this much, but there's all sorts of other symbols that could be used in our equations to help give us extra information. So we could say that we put a triangle over the arrow, and it just means that we heated it to make it happen. We could put a G after a substance to indicate that it was a gas, or an L to indicate that it was liquid, or CR indicates crystalline. AQ, dissolved in water, aqueous solution. So here's a few tips. If you're going to balance equations, one, you have to have the correct formulas. For what our limited time scale is, I will give you correct formulas. If we were writing out the formulas, you'd really need to remember, you know, what are the diatomic elements. Once you have the formulas correct, you may not change the substances. You cannot change the subscripts anymore because that would change the substance. So once your formulas are correct, the only thing you can change is the coefficients. So balancing the equation, the only thing we can do is put numbers in front. The next is just a tip. Oxygen is involved in so many different substances, so it's hard to know where to start with oxygen. Leave it for last. If you leave it for last, a lot of times it'll work itself out. Hydrogen, kind of the similar thing, but we're going to do hydrogen second last. And then, balancing equations is going to be pretty easy. But once in a while you get an equation that just gives you trouble. And so if you have like almost everything balanced, but you're down to like one last element and it just won't work, my suggestion is to go take everything you've already balanced and double everything on both sides. And then go back to that last element, and I bet it'll work. And I'll show you that in an example. If you have to pause and write some things down, go for it. All right, so let's just try an equation. So we've got sodium carbonate plus calcium hydroxide yields sodium hydroxide and calcium carbonate. Reactants yield products. Every time there's a plus sign, there's a new substance. Okay? So what I do is leave oxygen for last, hydrogen second last. Beyond that, I just start at the beginning. I see 2 sodium here. I look over there and I only see 1 sodium. And so I ask myself, well, how could I do that? If I double this, I'll have 2 sodium there. Now I'm going to go to carbon. There's 1 carbon there. There's 1 carbon there. Let's not mess with it. Okay. I'm going to leave oxygen for last. So let's look at calcium. There's 1 calcium there. And come over here. There's 1 calcium there. I don't want to mess with it. So I guess now I got to go to hydrogen. Now hydrogen is in parentheses. There's 1 in the parentheses, and then there's 2 of that group. So that means there's 2 hydrogen here. There's 1 in this formula, but I doubled that formula, so there's 2 hydrogen there. Hydrogen's done. So the only thing left is to look at the oxygen. And I told you, if we wait till the end, a lot of times it's worked out. So right here, there's 3 oxygen. Just to keep a track. There's 1 oxygen in the formula, but then in the parentheses, but then there's 2 of that. So altogether there's 2 oxygen there. So I have 5 oxygen total. Come over here. There's 1 oxygen in the formula, but I got 2 formulas, so that's 2 oxygen. And then there's 3 oxygen there. 5. It's done. So all I needed to do with that equation is put a 2 right there in front of the sodium hydroxide. Okay, let's try the next one. Start at the beginning. 1 calcium, look over here, 1 calcium. 2 chlorine, look over here, there's only 1 chlorine. So I'm going to double that guy. 1 silver, I just doubled my silver over here to 2, so I better double this to 2. 2 nitrogen, oh, well, there's 1 nitrogen in there times 2. There's 1 nitrogen in the parentheses times 2. I got 3 oxygen there times 2 is 6. 3 oxygen in the parentheses times 2 is 6. I needed to put coefficients in front of silver nitrate and silver chloride. Oh, let's see. We're not going to do all of these. Let's do the last one. Start at the beginning. Potassium, 1. Potassium, 1. Chlorine, 1. Chlorine, 1. Oxygen, 3. Oxygen, 2. How am I going to do 3 and 2? Now, remember, all I can do is put coefficients in front. So whatever is going to happen, it's going to have to be a multiple of that. All right? So I can put 2 or 3 or 4. And so my number of oxygen over here are going to be 3 or 6 or 9. My oxygen over here are going to be multiples of this. 2, 4, 6, 8. So what's the least common multiple of 3 and 2? I think that's 6. How many of these do I need to have 6? Well, I need to have 2. How many of these do I need to have 6? I need 3. So there's 3 oxygen times 2 is 6. There's 2 oxygen times 3 is 6. But now you have to remind yourself that I just changed the potassium into chlorine, so I have to go back and fix that now. So there's now 2 potassium here, so I'm going to put a 2 in front of that. And that 2 doubled by chlorine, but that 2 doubled. Oh, okay, so everything had to give some coefficients. 2, 2, and 3 makes it work. All right, when you go to the gas station, you fill in some gasoline. Despite what it says on the pumps, there's pumps in town that say 100% pure gasoline. That is kind of a non-statement. There is no such thing as pure gasoline. What they mean is that particular blend of gasoline doesn't have ethanol in it. And there's small engines, ethanol doesn't go well for your small engines. That's a whole different topic. But gasoline is a mixture. But one of the primary chemicals in gasoline is called octane, and it has got the chemical formula C8H18. And octane is combustible, which means we can burn it with oxygen. So just like that first equation today was methane combines with oxygen to form carbon dioxide and water, octane combines with oxygen to form carbon dioxide and water. And I want to balance this equation. Okay? 8 carbons. 1 carbon. I'll put an 8. 18 hydrogens. 2 hydrogens. So I think I'm going to try a 9. That would be 18, right? 2 oxygen. Right here I got 2 times 8 is 16 oxygen. I'm going to give myself a little reminder. And I got 1 times 9 is 9. And 16 plus 9 is 25. No matter what I do, I can't get 25 out of that. Not with a whole number. Okay? So this is that last tip that I gave where if everything's balanced, I got the carbon and hydrogen balanced, but the oxygen doesn't work. And I said, double what we've already done. So I'm going to go ahead and change this to a 2, which then is going to make 16 carbons. So I'm going to change that to a 16. And that's going to make 36 hydrogens. So I'm going to make that an 18, because 18 times 2 is 36. And now that's going to change my oxygen here to, let's see, 2 times 16 is 32, and 1 times 18 is 18, and that's a total of 50. And 2 does go into 50 evenly. I can have 25 oxygen molecules. So for every 2 octane molecules that you put in your gas tank, you need 25 oxygen molecules from the air to burn that. And when we talk about how much carbon dioxide comes out from a burning, I mean, look at all the CO2 that comes out of that just from burning 2 molecules here. Okay, so that's a little basics about balancing equations and some equation vocab. I'll give you some questions to practice.